Hi, Statistics Sifu here again with another Excel solver optimization exercise that you can use in your digital marketing or marketing analytics classes. Or if you're a student watching this video, it's just an opportunity for you to learn solver better by having another example to work with. So I use the Stukent Digital Marketing Essentials text in my undergraduate digital marketing class. And in chapter 13, Digital Strategy, they present a chart similar to the one I've got up here right now, figure 13.4.1, if you're following along in the text. I don't want to present the actual material, for copyright reasons, but it's similar to this one. The idea being that you can invest in different channels, but at a certain point, there are diminishing returns, right? So there might be some channels, in this chart in particular, that looks like paid search. We haven't come anywhere near the point at which we've reached that point of diminishing returns. But some of the others, they might start very high, but then drop very quickly. And in that chapter, they actually say, this could be, the optimal allocation of resources could be easily accomplished using a tool like Excel Solver. But then they don't supply an exercise that allows you to do that. So inspired by this, I decided to create this one. And, everyone's free to use it. So let's take a look at the exercise itself. So this is all synthetic data. I've made it all up, but basically what I've done is I've created only a 4-channel exercise, so it's a bit simplified, but we're looking at an email campaign, paid search, paid social, and display advertising, and we've got 2 years of data where they've done some tests, where they've invested various amounts of money across the different months to get a sense of like what type of return would we get. And so we're not going into the details of how they're attributing revenue, and of course that's a very interesting question unto itself. But for our purposes, we've got a certain amount of revenue attributed to the investment made in each of the channels. As that chart showed, though, that over time, that you can't just continuously invest in a channel, even if it's really profitable. At a certain point, there probably are diminishing returns for various different reasons. But because there are diminishing returns, we are not going to model these as linear trends. Instead, we're going to model them as polynomials of an order 2. And I'll show you how to do that. So you actually do need to estimate, what does the equation look like? And we don't even need to go into anything like the data analysis tool pack. We can actually just use the solver scatter plots and trend lines in order to do it. So it's a pretty straightforward, relatively simple exercise for Excel users. Even if you don't have a lot of experience with Excel, hopefully it's something that can be learned pretty quickly. So here I've got 2 columns of data plus the dates. We're looking at the email tab specifically, and I've actually included the instruction here, fit a polynomial trend line order 2 to each data set. So I'm taking a little bit of the uncertainty out of this. So I'm going to highlight the 2 columns here, spend and attributed revenue, and I'm going to go to the scatter plot. And so you should get the scatter plot here, where you can see the amount invested down here and the return. And if I click on any one of these points, I can go to add trend line. And now a linear line here doesn't do a terrible job. Actually, if you wanted to see, we can display the equation on the chart and also the R squared. It gets us a 55.26% R square. But as the instructions tell us, that's not what we're going to fit. We are going to add a polynomial trend line of order 2. A little wider, okay. And if I just check display equation on the chart and display R square value on the chart, you can actually see we get a much higher R square, 71.2%, which suggests that line actually does fit better. So I'm going to clear this out of here, and actually this line I'm going to delete that too. So that's really the chart you're going for. And the reason why we do this is to get this equation that's going to be important for us in our solver exercise, because we're going to use that to predict the amount of revenue associated with a specified investment amount. Okay. Now we have to repeat the process for each of the different campaigns. Same thing here for paid search. So I go to that tab, I highlight the 2 columns of data, I say insert scatter plot. There's my scatter plot. I'm going to add the trend line, polynomial order 2, so that accounts for the diminishing returns. Display equation on chart, display the R square value on the chart. So there we go, we got that one. Go to paid social, same thing, highlight the 2 years worth of data, insert, scatter plot. Click on any of the dots. I'll go to add trend line, polynomial order 2, display the equation on the chart, display the R-square on the chart. And really, the purpose of displaying the R-square on the chart is really just to show that the polynomial function fits better than the linear function. We're not really doing a model fitting exercise here. We just need to get equations to describe the relationship. All right, so I go insert, scatter plot one more time. This is for display advertising. Adding a trend line, polynomial order 2. I guess really we just need to display the equation on the chart, but I'm in the habit of doing both. Also including the R-square. So there you go. There are my equations. Once you have the equations, we can look at the last tab, the solver exercise. This is actually where we're going to set up the solver exercise itself. And we're going to use those equations that we just discovered with our trend lines. We're actually going to paste those in here. So I'll come back here after we've got the equations ready, and then I'll walk you through this setup. So let's go back to the email tab. Unfortunately, it's not so easy to just copy and paste this formula, so we do have to type it up. The way that those formulas are set up in the solver exercise, you're going to have to reference this X as the investment level. That's going to be in the cell next to it. So we're just going to use that as a placeholder for now. I'm going to type the equation here and then just copy and paste it over there. So be careful, make sure you don't miss these negative signs. It's -0, so it's equals -0.7116 times that placeholder cell, and then I'm going to square it by using the caret symbol, which on the PC is going to be shift 6, right? 2, because we're squaring it, plus 209.01 times that placeholder cell, minus 10309. So that's the equation. Right now it's calculating that, treating this as a 0. But if you wanted to see, what that looks like if I put in that last data point, here's my projected revenue. This is the actual revenue, the observed, 4,606. So, just to test to see if your equation is right, just make sure that that number is in the right ballpark. It's not going to be exactly the same. But so I can copy this now. I just did Control-C, but you could also do with your mouse, copy, right? I go over to the solver exercise, and you can either do with your mouse, right-click, and then paste, or you can do Control-V. Paid search, we're going to do the same thing. Equals -0.0034 times that placeholder cell squared plus 8.4921 times the placeholder minus 1042.5. I'm going to copy this. I'm going to put it right here. Actually, the reason why I'm losing that currency thing is because I'm pasting. All right. Next will be paid social. So same thing again, equals -0.0102 times the placeholder cell squared plus 8.8587 times the placeholder minus 681.13. Again, if you wanted to just check, it's in the right ballpark, right? So. And then for display advertising, equals -0.0076 times the placeholder cell squared plus 5.2447 times the placeholder minus 231.06. And if I want to check this, yeah, it's in the ballpark, 339, 336. Paste that in there. All right, so right now it's treating everything as a bunch of zeros. And that's why we're getting just those negative intercept points that we had. Let me just go back to paid search real quick. We'll double check this one, make sure it's calculated properly. All right, it misses by a bit, but it seems it's in the ballpark at least with the 494. Okay, just double check. Okay. All right. So I've got the formulas here in the projected revenue. You can see here that there's already a formula here for total projected revenue. It's summing that up. Again, we are not going to populate these ourselves. We're going to let Solver populate that. These are our changing cells. So in Solver, you have to have an objective cell, and then you have changing cells. So Solver will try different values to see if it can get a better outcome on the objective. You won't necessarily have constraints in any Solver problem, but certainly in this one we do because we have a budget. And so we're told down here, determine the optimal allocation for a $1,000 budget, $1,500 budget, and a $2,000 budget. And so you get to see how that changes when your overall investment level changes. Like you might invest a higher percentage of your budget in one channel under one scenario than you do in a different scenario. All right, so to go to Solver, it should be under the Data menu. If you click on Data, it'll be all the way over to the right. If you don't see it there, it just means that you haven't activated the Solver add-in. And I'll include a link in the description with the instructions on how to do that. It's actually a pretty straightforward process, but it looks a little bit different if you're on a Mac versus on a Windows machine. So I'll leave that. I'll leave the instructions for both there. All right, so click on Solver, and you should get the Solver parameters box that pops up. Our objective cell here, I'm going to click on this, is the total projected revenue. We want to maximize that by changing these cells. I'm highlighting the whole group of cells. Subject to the constraint, so I have to add a constraint. The constraint here is the total budget, and we'll start with the first scenario, $1,000 budget. So less than or equal to 1,000, and then just click OK. Now there are several solving methods, 3 of them actually, for Solver. GRG nonlinear is the appropriate one for this particular problem. We have equations that we're using that are not linear in nature, so you can't use the linear version, which when it's correct, is really quick, but if it's not correct, you can't use it. The more complicated one is the evolutionary solver, but the only time you would need to use that is if you've got conditionals, like if conditions embedded in your equations that you're using, that you're trying to optimize. So in this case, GRG nonlinear is the appropriate one. So we've got the $1,000 budget set. We've got our objective. We've got our changing cells. Go ahead and click Solve. And you have to click OK to hold on to this solution, but we're told with a $1,000 budget, we can get a total projected revenue of $8,585. We're investing $143 in email. Over here, these values are just showing you your RPDS, your return per dollar spent. And you can see email, it's great, but the nature of the equation is such that you get very quickly diminishing returns. So even though, like, why wouldn't you want to continue to invest if you're making that much more? Display at this investment level, we're not doing very well. Paid search and paid social, you're getting a pretty decent return, nowhere near this $35 an email, but certainly there's more people that we can reach out to. Email usually is used more for loyalty purposes where you're contacting existing customers, whereas paid search and paid social, you're reaching out to, especially with paid search, you're reaching out to like the overall prospecting pool. Okay, let's see. If we change the solver constraint for a $1,500 budget, what happens? So I'm going to click on the constraint. I click on change. I'm going to change that value to 1,500. Click OK. See that that's been changed. Then I click on solve. And it runs it pretty quickly when it's a simple, a simple question or a simple scenario like this. So I'll click OK. And you can see here, our spend on email didn't go up very much, even though our budget increased by 50%, showing that we're probably getting kind of to the limits of email. We spent quite a bit more on paid search, and then also paid social. We increased our spending on display as well, and actually our performance on display in terms of the return per dollar spent has improved quite a bit as well. So we needed to reach a certain critical mass, I guess, with display in order for that to become more profitable. For that extra $500 of budget, we were able to generate we went from 8,000 something to 10,000 something, so we got a decent return. All right, the last scenario, let's see what happens if we change our budget to $2,000. So I'll change that constraint to 2,000, click OK, and then I'll rerun Solver one more time. And so our total projected revenue now goes up to $11,156 on our $2,000 budget. Again, email, we did not increase a lot more. We're kind of settled into that $34, $35 range in terms of our RPDS, but with a limited audience. It looks like a lot of the money goes to paid search as the budget increases. Paid social went up a little bit. Display is now getting, again, a little bit better return as well. So that's an example. You could simulate higher budgets if you wanted to. Because this is a simplified example, if you start going outside the range that we looked at, you might get some pretty nonsensical answers. Again, it is an oversimplification, but it's just an exercise to get you familiar with how Solver works. So like in chapter 13 of the Stukent Digital Marketing Essentials text, they said, if you have the information to set this up, you can easily determine your optimal allocation using a tool like Excel Solver. So hope this is helpful. See you next time.